Hey everyone. So the question that we are going to solve today is path with maximum probability. So what does this problem state? That we will be given a graph in the form of edge list. Like for example, we have a graph with three nodes and edges from 0 to 1, and another edge is from 0 to 2, and one is from 1 to 2. So and along with this we will be given the probability. This is the probability of success, which means that what is the probability that if we go from this path, if we choose this path, so what is the probability that we will reach this node? Starting from this node, if we choose this path, so what is the probability that we will reach the node 1? It is 0.5. Similarly, if we start from node 1, so what is the probability that we will reach the node 2? It is again 0.5. And if we start from node 0, so what is the probability that we reach node 2? It is 0.2. So it will be given to us. We will have, and along with this we are given a start node. Let's say the start node is 0, and we will be given an end node. Let's say end node is 2. So we will have to find that what will be the highest probability we can achieve to reach end node from the start node. What is the highest probability of reaching end node from the start node? What does this mean? So so out of all the paths, like we can go from 0. If you want to reach to 2, what all paths do we have? We can go from directly from 0 to 2, because there is an edge from 0 to 2, so we can reach directly. Or what can we do? Like if we from 0, if we go to 1, after that we go to 2, following this path, we have this option as well. So what can we do? Like if we choose this path 0 to 2, what will be our probability? It is given that to reach 2 from 0, our probability will be 0.2. Okay, and in this case, if we go from, firstly we will go from 0 to 1, and this time our probability is 0.5, and to reach from 1 to 2, our probability is 0.5. So the probability to reach 0 to 2 following this path will be 0.5 into 0.5, okay, which is 0.25. So this path is giving probability as 0.2, and this path from 0 1 2 is giving probability as 0.25. So 0.25 is greater than 0.2, so our answer will be 0.25 in this case. Okay. Okay, suppose we have 0.3 here. So the probability of the path from 0 to 2 will be 0.3 directly, and this path is giving probability 0.25 as we calculated before. So in this case, the probability of 0.3, the probability of the probability by the probability we get by following this path is high, because it is 0.3, and the probability we get by following this path is 0.25. So our answer in this case will be 0.3. So similarly, we have to find this we have to find that what is the highest probability we can get of reaching of going to end node from the start node. What is the highest probability we can get? In order to solve this problem, you should know Dijkstra algorithm. If you don't know Dijkstra algorithm, I would highly recommend watching a video of Dijkstra algorithm first, and then come back to this video to understand better. So what does Dijkstra algorithm do? Dijkstra algorithm gives shortest path from source to every other node in a graph. So if we are given a source, so Dijkstra algorithm will give shortest path from this source to every other node in a graph. So how can we use Dijkstra algorithm here? We are given a graph, and nodes and vertices are there, which are showing the probability of reaching from one node to the other. So what can we do? Like we do in a Dijkstra algorithm, if we maintain a priority queue. But here, instead of min heap, we will maintain a max heap. And why are we doing this? I'll tell you. We will maintain a max heap. And initially, like what do we do in Dijkstra algorithm? Like the distance array, which gives the shortest distance from source to every other destination. What we do, let's say our source is this node. Okay, this is 0 1 2 3 4, let's say. Oh, here we have 3 nodes, so I'll take only 3 nodes. This is 0 1 2, and here let's say our source is 0. So this is source. What do we do? Then the shortest path of reaching from 0 to 0 is 0. We keep 0 here. But here we are calculating probability. So what will we say? That the probability of reaching, the highest probability of reaching 0 from 0, what should be? It should be 1, because because reaching a node from the same node is uh, always possible, because we are already present on the same node. So uh, we will keep the probability of reaching source from source as 1.0. This thing will be done initially, and after that, what will we do? We will push this thing into the max heap, uh, which will store pairs. So what will we do? First, uh, in the first part of the pair, we will store the probability of reaching a node, and the second, and in this second part of the pair, we will store that node itself. So we will store this thing in the max heap. After that, we will start the loop which is used for Dijkstra algorithm. Like, we will explore every other path that we can reach, every other node we can reach from this node. Like from 0, where else can we reach? We can reach 1 and 2. Like, we stored 1.0 for the source node, and for the other nodes we will store 0. Initially we will store 0, because we don't know that what will be the uh, highest probability of reaching those nodes starting from the start node. So we have stored 0 initially, and we will keep on updating these answers if we find any more suitable answer for these nodes. Okay, so initially we have the distance and the node, the probability and the node. Okay, so from 0, where else can we reach? From 0 we can reach node 1 and node 2. Okay, from 0 to 1, what is the probability? It is 0.5. So what is the probability, the of current probability of node 1 reaching node 1? It is 0. So, and what is the probability that 0 is given, that this path is giving to node 1? What is this path giving? Like, the probability before this, the probability before this is 1, that to reach 0 our probability is 1. And to reach from 0 to 1, what will be our new probability? The previous probability into the current probability of this path, that the current probability of this path, like this will be 0.5. So which is better than 0? The previous probability of 1 was 0, so 0.5 is better than 0. So what will we do? We will update 0.5 here, and store it as here. Okay, and store it as, and store it here, like 0.5 for 1. Similarly, what else path do we have? We have another path as this one. From 0 we can go to this path as well. So what is the what probability will we get for 2? 2 is initially having probability as 0, and this path is giving probability as 1.0 into 0.2. 1.0, because the probability till this path is 1, and this path is giving probability as 0.2. So this will become 0.2, which is better than 0.0. So we will update the probability of reaching of reaching the node 2 from 0 to 0.2, and we will store this here in the priority queue. The nodes will be stored in sorted order. Okay, and we will remove this value, like 0. So now I will tell you that why are we storing, like, now I will tell you that why are we storing in max heap instead of min heap. Because what do we do in Dijkstra algorithm? We find the shortest path. So that's why we need the smallest value at the top, smallest value at the top, so that we can find the minimum value as soon as possible. But here we are calculating probability, and we need probability as high as possible. So that's why we are keeping the greater value at the top and smaller value at the bottom. I hope you got it. So now we will calculate for 1. From 1, where else can we reach? From 1 we can reach to 0 or 2. Okay, so firstly let's calculate that what is the probability we will get if we go from 1 to 0. Initially 0 is having probability as 1. Initially 0 is having probability as 1. And what is the probability till 1? It is 0.5. So what probability will 1 give to 0 if we go from 1 to 0? It will give 0.5 into 0.5, because till 1 the best probability that we have is 0.5, and if we go from 1 to 0 the probability is 0.5. So the new probability that 0 will get will be 0.25, which is not more than 1, which it already have. So we will not update the probability for 0, and we will not add uh, any new entry for 0. Okay, so from 1 we can reach 2. From 1 we can reach 2. Okay, so what probability will 1 give to 2 if we go from 1 to 2? 1 is having probability as 0.5. 1 is having probability as 0.5, and the probability of going from 1 to 2 is 0.5. So the probability of reaching 2 will now become 0.25, which is better than 0.2. So we will update this value. So the new probability of reaching 2 is 0.25. So we will update this value, that the new probability of reaching 2 is 0.25, which is better than the previous probability that was 0.2. Okay. Okay, so now when this value got stored, it came above this value, because 0.25 is greater than 0.2. Okay, so now if we calculate for this value, like from 2, where else we can reach? We can go reach 0 or 1. If we go to 0 from 2, what probability will come for 0? Like the probability for 0.2 is the probability for the node 2 is 0.25, and the probability of reaching 0 from node 2 is 0.2. So what is so this is about 0.05, I think. So it is 0.05, which is not better than 1, because 0 is already having its probability as 1. So we will not update this, and from 2 we can reach 1 as well. So what will be the new probability for 1? It will be 0.25, which is the probability of reaching 2, and 0.5, which is the probability of reaching 1 from 2. So this will become 0.25 into 0.5 will be 0.0125, which is less than 0.5. So we will not update the probability for 1, because it was more than this value. Okay, so now this entry is also erased from the max heap. Now we have only one entry left, which is 0.2 comma 2. Similar thing will happen, like from 2 we can reach to 0 or 1. If we go to 0, what will be the probability we will be getting for 0? It will be 0.2 into 0.2, which is 0.04, which is not more than 1. Okay, which is not more than 1. So we will not update this thing, this thing, because we already have 1, and from 2 we can reach 1. So what will be the new probability we will be getting? It is 0.2 into 0.5, which is 0.01. So which is less than the already existing answer for 1. So we will not update the value of 1 in this case. So this entry will also be removed from the priority queue, and now hence our priority queue is empty. We will stop this process, and the our destination, that was 2, and this was our start point, and this was our destination. So now we will return the probability that is stored at this index, that the index for 2, because this is the highest probability out of all the paths. out of all the paths that are available from 0 to 2. Out of all the paths that are available from 0 to 2, the highest probability will get stored in this path. So we will return the value stored at this index. So now I will show the C++ code for the same. First of all, I am creating an adjacency list to store the values so that I can access them easily. And what am I doing in this for loop? That if the success probability of reaching from a node another node is 0, which means that if we go from a node to another node, and if there is no if the probability is 0, so there is no point in adding that node to our adjacency list, because it will be it will be redundant. So I am doing that if success probability is 0, I am not considering that node into my adjacency list. After that, I am creating a priority queue which will be of the type max heap, because I want to keep the values with more probability at the top and the less probability uh, at the bottom. And what am I doing? I am pushing this value to the priority queue 1.0 comma start. 1.0 is the probability of reaching to the start node from the start node itself, which will always be 1, and this is the start node. So in the first part of the uh, priority queue, I am storing the probability of reaching to the node, and in the second part of the priority queue, I am storing the node itself. Then I am creating this probability array, and uh, which will store the probability for every node. We have n node, so this will store the probability, the maximum probability for every node. Initially, I am setting the probability for every node to be 0, because we don't know that what is the probability. So we will store 0, and the probability for start node is set as 1, because we can always reach to the start node starting from the start node. So that's why it is set as 1. And now what am I doing? While the priority queue is not empty, which means that if we have any value to be checked, we will check it inside this while loop. And and first of all, we will extract the values of from the priority queue one by one, and this thing is done in these 3 lines. After that, what am I doing? That the current node which I have extracted here, and this is the distance, that the total probability, the highest probability of reaching to the current node from the start node, this is stored here. Current distance is showing that thing. So what am I doing in this for loop? That all the adjacent nodes of the current node, if they are holding their probability to be less than the probability this path is giving to them, that the path of current node, if the path of current node is giving them the probability more than the probability they are currently having, so I will update their probability to the probability the current path is giving to them. Okay, this is the current distance is the probability to reach, the best probability to reach to the from the start node to the current path, and this d is the path between the this node and the current node that we have extracted here. So if their previous probability is less than this probability, I will store this new probability here, and then I will push this entry to the priority queue, because this entry might give me any better answer in the future. So I will keep on doing this until my priority queue gets empty, like I showed in the dry run. And after that, I will return the probability of the end node, that is our destination node. This index will store the best probability for the end node, so we will return this. And this is the code for this. Thank you so much.